In this standard 8.F.5, which is the block of function standards in 8th grade, we're describing qualitatively the functional relationship between two quantities by analyzing a graph. And usually these situations are non-linear. So as we can see here, the graph in this problem represents the total profit in dollars for Demetrius over time in months. So the first part that we're supposed to answer is Demetrius starts off with a total profit of blank. Well, that's essentially asking for the initial value, which happens to be right there. And so that would mean that Demetrius started off with $3. So let's go ahead and fill in that value. Part B, what is Demetrius's profit after 5 months? Well, 5 months, as we can see by the x-axis label right here, we're talking about an x value. Well, of course, 5 would be right there. So in a situation like that, we would go down to where it hits the graph and straight over. And so it looks like he was in debt at that point. In other words, his profit at 5 months was negative $3. This graph shows a total profit, shows total profit for a total of so many months. So this starts at 0 months. The graph starts right here at 0 months and goes all the way to 7 months right there. So for a total of 7 months, because what this problem is doing is comparing Demetrius's profit over a certain number of months, from 0 months to 7 months. Demetrius's profit remained the same from what to what? Well, same means we're looking for a part of the graph that is constant. So we're looking right there from 4 months to 5 months. His profit was constant, which means it was the same. So from 4 months to 5 months. Part E, Demetrius's total profit increased from 2 months to 4 months. So if we look at the part from 2 months, which right there is 2 months, if we go up to the graph, it's right there, to 4 months, there's 4 months down to the graph. So we're talking about this part of the graph right here. So the question is asking whether his profit increased. Well, clearly, that part of the graph is decreasing from 2 months to 4 months. So therefore, this is a false statement. Demetrius's total profit decreased from 4 months to 5 months. Well, we've already talked about from 4 months to 5 months. That's this part of the graph right here. That's constant. Constant means it stays the same. It didn't increase. It didn't decrease. So that part is also false. Standard 8.F.5 in the functions block of standards in 8th grade describe qualitatively the functional relationship between two quantities by analyzing a graph. Most of the time that's dealing with some sort of non-linear graph, which is what we have in this situation. So this problem is dealing with or shows the graph of a person who draws comic strip panels. And for each customer, he determines his initial price in dollars based on the number of comic strip panels the customer orders. And of course, the graph shows that situation. So the first question being asked is the number of panels a customer can get for $100. Well, if we look at the graph, $100 is found right there. So if we go over to our graph and straight down, it looks like the customer can order around 7 panels, but we're not being asked for an exact value, because what we're supposed to do here is indicate whether each of these values is less than 10, equal to 10, or greater than 10. Well, no matter what that value is, clearly it is less than 10. The cost in dollars to get a single panel. Well, it's very difficult to tell. Single panel means one panel. If we go up to the graph and straight over, it certainly is less than $20, but it's very difficult to tell whether it's less than $10 or not. So we've got to find a perfect value. So if we go to right here, since that part of the graph is all increasing at a constant level, we can see that it will cost $60 for 4 panels. Well, that means if it's $60 for 4 panels, that means it would be $15 per panel. In other words, 60 divided by 4, coming across the idea of the unit rate, which you did in the 6th grade and in the 7th grade. So clearly, that is a value that is greater than 10. The average cost per panel when a customer orders 4 panels. Well, we kind of already answered that question. 4 panels in this particular problem cost $60, but this is asking for the average cost per panel. So once again, 60 divided by 4 is $15 per panel, which once again is greater than 10. And then the average cost per panel when a customer orders 12 panels. Well, if we find 12 panels on our grid and go straight up to our graph and straight over, that looks like that's around $150. But remember, we don't have to get exact. We're just trying to see whether that value would be less than 10, equal to 10, or greater than 10. Less than 10, if we're buying 12 panels, would be some value less than $120. Equal to 10 would be if we paid exactly $120. But 120 is right here. Clearly, this value right here is going to lead us to a value greater than $10 per panel. In this standard 8.F.5, where we are describing qualitatively the functional relationship between two quantities by analyzing a graph. Well, there are times in this standard where you actually have to sketch a graph that has to do with those things. So that's exactly what we're doing in this problem. So if we start by reading the problem, this problem is comparing Paige and her phone, the percentage charge to the current time. So the problem starts off with Paige's smartphone is at 100%. And we're looking at this part of the problem right here. Okay. And it remains that way until she starts using it at 1 p.m. So right there is 1 p.m. She uses the phone for 2 hours. And during that 2-hour period, she drained the phone down to a charge of 60%. So 1 hour, 2 hours, but it's now drained to 60%. Paige then decides to stop using her phone. She does so for 2 hours, and the phone remains at a constant percentage. So 2 more hours stays at 60%. She then decides that she needs to make a long phone call. So she plugs her phone in so that her phone can charge during the call. The phone call lasts 2 hours and the phone reaches a charge of 100%. So 2 hours, back up to 100. Paige's phone remains at a charge of 100% for the next 1, 2, 3, 4 hours. And that's what the graph should look like. So we did part A, which was creating the graph. And then part B down here, it asks for the rate of change for the time period from 5 p.m. to 7 p.m. Well, 5 p.m. is right there. 7 p.m. is right there. So for that part of the graph, we're looking for the rate of change. In other words, the slope. So we would be rising, and we're going by tens here, it looks like. Rising 10, 20, 30, 40 for 2 hours. So rate of change, we can think of that as the same value as the slope. So that would be 20% per hour. And there is how we do a problem where we have to graph the qualitative situation.